industry in terms of policy, sustainability and technology convergence is self-evident. It means that our paper industry will be ready for all the transformation and technology required for that. In the past 1 decade, our paper industry has transformed a lot. And what I foresee in the coming 1 decade, our paper industry will become a change which other paper industry will witness. So, in integrated pulp and paper industry, the major cost factor is the cost of good manufacture. It varies 45% to 55% of the total revenue. Second major cost factor is fuel and energy cost. It varies from 12 to 15%. And if you see fuel and other energy expenses already skyrocketing. And if we see, if an integrated paper industry has a turnover of 1,000 crore rupees annually, almost 130 to 150 crore rupees is the for fuel and energy expenses. And these fuel and energy expenses in integrated paper industry is only 60% of the total energy. Remaining 40% energy is contributed through the recovery boiler. And in Indian paper industry, most of the recovery boilers are firing solid concentration at the rate 60 to 65%. And there are only few industries who has just the 70% solid concentration. At 60 to 65% solid concentration, the specific steam generation is 3.1. But this black liquor solid have a potential that it can produce even 5 tons of steam generation provided that it is 100% dry. 100% dry solid content may not be possible with the available technology. But it is quite evident that 85% of the solid concentration is already achieved. I'm explaining that. I'm coming to the point. So why I'm explaining that? This is the background of the PPT which I am going to explain, because some of the people are not aware about the how it impacts, but it is the business impact. That's why I'm explaining the thing, how it is actually impacted. So there is an urgent need in the paper industry that this solid concentration in India will also increase. And in Indonesian industry already has achieved. So that if the solid concentration increases to 80%, what will happen? How it will behave? How our income statement will change? What will the total impact will be on the company profitability? I am going to explain those. So, to achieve the 80% solid concentration, at least at Indian paper industry top, what is the technology? What will be the change? I am going to explain about those slides. And first, let us understand what is the unique selling point of those. Suppose solid concentration being fired is 66%. It reaches to 80%. So, fuel and energy expenses will reduce to 12% to 9%. Means almost 30% of the fuel and energy expenses has been slashed down. Worth rupees 30 rupees. So, boiler recovery thermal efficiency will increase from 60% to 70% at this level. And the SPM will reduce from 100 to 20. I will explain how it will happen in the coming slides. First, I have explained all the unique selling points. So, by adoption of this technology, what I am going to explain, the PPT schematic diagram is about to come. The steam economy of the evaporator will also increase to 8. Till now, in the multiple effective evaporator system, 6.5 the highest steam economy was achievable. In Indian paper industry or elsewhere, being generated. HP steam, MP steam, LP steam. But it doesn't mean that the lower pressure steam cannot be produced. It can be produced. Even at room temperature, steam can be produced, provided that what the atmospheric condition on the solution is. If it is in a vacuum, it can produce the steam. And that heat has to be utilized. Already in evaporator, vapor being utilized under the vacuum. So that heat will capture by the humidification, dehumidification system. Another thing is that this concept is basically a net zero concept. Net zero emission, zero liquid discharge. So bleaching chemical will also reduce, and the humidity of the flue gas will also increase to 50%, which is required actually. We are taking air at 35 degree ambient temperature and expelling it at 165 degree. So this concept will, what is has taken from the environment, it will discharge at the same temperature. So sustainability point is intact. Ground extraction water will also reduce because it is regenerating low TDS water from the wastewater. So this is the two heating surface super concentrator for black liquor. If you see closely, bottom portion act as a forced circulation, top portion act as a free flow falling balloon. This is a special type of super concentrator. What is the change in here? In the existing technology or conventional technology, when we are employing the super concentrator, viscosity increases huge. What happens actually due to viscosity? When the viscosity increases, friction losses also increases, almost 10 times. Means if the pump has efficiency at 5 CP, efficiency 70%, it will drop to 10%. You have installed a pump, you will think that it is consuming the power actually, but it is not transferring the liquor into distribution power. You are thinking that it has silica, actually it has the wetting rate. So proper designing of the black liquor super concentrator is utmost important. I will not bring the team into the Nassart number, Reynolds number, because that will become the so fuzzy. So I want to explain the simple thing. This is a super concentrator, and you have to simply put a firing temperature, firing solid concentration, and that's it. And it will control automatically by the refractometer. And another thing important is that, suppose by the conventional technology, in the Indian turf, you have produced the 80% solid concentration and stored in the HBL tank, it will not come up because as it loses the temperature, viscosity will increase and it will not fall. In the out of India, India, they have pressurized tank. Even having the pressurized tank, still they have a lot of issues, extracting and firing. By this technology, this has ample inventory of 2 hours. Means if some issues come, still it will have fuel for the recovery boiler. If you see, whatever the firing you have to put, fire in the recovery boiler, simply put the set point, this auto control valve will feed it into the distribution box. Why it is important? Because in the most of the agro-based liquor, they are firing the liquor 50%, they are transferring to the cascade evaporator, then from cascade evaporator, it is being fired in the recovery boiler and getting only 2.5 ton of the steam generation instead of getting more than 3 to be economically viable. So, this is the technology of super concentrator. So, let us talk about what is the setback with the conventional technology. As the viscosity increase, especially of the agro-base, as I earlier explained, the required power, torque, and many things increases. But when it is in the pressurized system, supposed to maintain the viscosity, some of the people are adding the white liquor. But white liquor will not generate the steam. When you add the white liquor, viscosity will be slightly dropped, the specific steam generation pattern solving will reduce. What is required? You have to increase the temperature up to 160 to 165. Material will remain pressurized in the super concentrator. You have simply to fire. Auto control valve will open and fire it. Because it is 165 degree and we have to fire at the 135 temperature. It will reduce the temperature indirectly. There is no need of any external indirect heater, direct heater. And reducing the temperature is much easier as compared to increasing the temperature, because when the solid concentration is high, it will plug the tubes. But when it is in the pressurized system, viscosity is low, pumping is easy, solid concentration achieving is also easy. The super concentrator is designed such that the upper section get proper wetting and the lower portion is already 100% wetted. So jamming issues is also reduced. There will be basically two concentrators. After 1 week you can bypass one concentrator and you can dilute it with a WBS. So that will come in the circuit, this will come into the line. So as I explained, I am coming back to the setback. Storing. If in the conventional system, if you extract the 75% or 80% solid, you have transferred in the HPL tank. Extraction is very difficult. I am repeating the point. And third is, even if you have extracted, then after adding salt cake mixing tank, ESPS, this will further fluctuate the firing. We need a fixed firing in the recovery boiler so that the minimum disturbance is there. Low temperature issue in the conventional system is there, but it is resolved in the proposed system, because we have to reduce the temperature, we have to increase that, we have to brought down from 165 to 135 degrees. So what is the distinction in the conventional proposed two heating surface flow? In conventional flow, you are extracting the WBL from HBL tank, transferring to ESPS tank, then salt cake mixing tank, then indirect heater, direct heater, and firing. In the two heating surface concentrator, you have to simply transfer the HBL of low concentration. Suppose if you have a gas mill, you will be extracting 55% solid. You are transferring to the two heating surface concentrator, and it is firing above. So casket will be permanently removed. If it is the wood liquor has already prominent, it is a good quality. So, but above 70%, we have limitized ourselves, but it is totally fixed down. So HBL to two heating surface concentrator, then indirect cooler. It is not direct, it is indirect cooler. Temperature is brought down, then fire. So, if you are installing one body, it will cost around 5.5 crore rupees per body. If you have two, then it will be 10 to 11 crore rupees for 700 TDS. So, what will the OPEX? OPEX will be 400 rupees for the steam, almost, and 50 rupees for the power, 450 per ton of the solid. This will be the operating expenses. These are the benefits. The gain in the steam generation annually will be around 25 crore rupees. Coal reduction will be 18. I will, if anyone needed, I will give the whole Excel sheet I have calculated. Because when your solid concentration is high, so specific air requirement will also reduce in the recovery boiler. Reduction will increase, and steam economy in evaporator will also increase. And steam saving, because already previously you've been increasing the temperature through the direct heater, indirect heater, that will also reduce. That saving is calculated 3.15. Total lump sum 50 crore rupees will annually be saved. And ROE, let us talk about the ROE. 50 you have invested, 14.2 the operational expenses. This is the means within 1 year your return, your payback is realized maximum. Now let us come to the fuel residue management. Recovery boilers flue gas usually of temperature 155 to 165 degrees. So wrapping up, sir. I understand. So basically it is heat capturing. At this particular temperature, flue gas has capacity to carry away 2.4 ton of the water in it at this particular temperature. So I am explaining how it actually works. Flue gas move this way and wastewater move this way. So due to counter current, first we have to understand the psychrometry. This is the psychrometry. If the temperature of the flue gas is there, this can carry away this much water, 2.6, at 150 at 2.5, and 100 degree at 0.622. Means this much water has been condensed on the dehumidifier. When you are adding the water, actually you are humidifying them. So nutshell, I am coming to the point. Gain is 65 crore rupee, investment is 20 crore rupees. This is the operational expense. This is also less than 1 year. Actually, slide is longer. I am apologizing for that. But the subject is such that. So conclusion is that black liquor solid by 80% is achievable. Deretor steam consumption can be reduced. Low TDS water can be produced. It is covering almost 85 to 90% of the water which is meal required per day. And this is basically net zero. And pulp shrinkage can also be avoided. And specific steam generation, as I already explained, can be increased. Waste heat is being captured. This is basically net zero, and climate change can be started from here. Thank you for your patience. I have taken a lot of time. Sorry.